Hi there, grade 12. All right, I guess this makes you guys the superstars of the class because you're doing a little extra work right now just because you're curious, and that makes me really happy. I can see who's watching this video, and I give you all gold stars. So what we're going to do in this video is we're going to look at how we can manipulate what's happening in a problem in order to solve one of these types of questions using these formulas. And that's going to rely on some information that we did using frames of reference, which we did a really long time ago, and we were able to do that all together, which was fantastic. So just to remind you what the question was, I'm going to have a quick look at it right here. So we have a 15 kilogram ball moving at 18 meters per second south, which experiences an elastic collision with a 6 kilogram ball moving at 9 meters per second north. Now we're going to figure out the final velocity of each ball. Now one option to do this is to use that specialized equation set number 2. But we can manipulate the problem a little bit in order to use set 1. So maybe you find this a lot to try and keep track of and substitute, and you really didn't mind frames of reference way back when we did that. So there is a little trick that we can do there. Just by subtracting a number, we can make the substitution so much easier for ourselves. So this is the full solution. That's it. And it looks like a lot only because I've actually written out what all of my variables are up here. Okay, now you don't really need to write all of that. You can go straight to that substitution. You may need to write the velocity bit a little bit, or the velocity lines a little bit, but that's up to you. So I'm going to keep variable 1, the 15 kilogram mass, and we know that that 15 kilogram mass was traveling at 18 meters per second south relative to the ground. The variable 2 was our 6 kilogram mass, and that's traveling at 9 meters per second north relative to the ground. Now, in order to use specialized equation set 1, we need one of those two objects to initially be at rest. So what I'm going to do is figure out the relative velocity of one of these objects relative to itself. Now, if you remember from relative velocity, we know that the velocity of, say, object B relative to object A is the velocity of object B minus the velocity of object A, where this velocity and this velocity are given with respect to the same frame of reference, usually the ground. So we learned this back when we did relative velocity. You may also see this in calculus and vectors in the relative velocity section. And that is the principle that we're going to employ to manipulate this question. So what I'm going to do here is I'm going to subtract that 9 meters per second north from my first object and from my second object. And that means that this object we called object 2 is now at rest relative to itself. So I can use specialized equation set 1, which shows us that m1 minus m2 divided by m1 plus m2 multiplied by v1. Now this gives me a new velocity. This is the velocity of object 1 after the collision relative to object 2. Now over here, for our second object, we have 2 times m1 divided by m1 plus m2, and we're multiplying that by v1, and that gives us a second value right here. This is the velocity of object 2 after the collision relative to object 2. Now, up here, we subtracted 9 meters per second north in order to change our frame of reference. We're going to have to undo that step at the end. So over here, if I want to change back to our initial frame of reference, we're going to just do the opposite thing we did. So instead of subtracting 9 meters per second north, I'm going to add 9 meters per second north. And that's going to take me from my manipulated frame of reference back to the frame of reference that we started with. And you'll see when we do that, we get that same 2.57 and 29.6 meters per second south that we had before. So you don't have to do the problem this way, but I did want to show you that there was another option specifically because it tied back to that section 1.6, which we haven't done in a while. But I don't want you to forget about these previous sections because sometimes we can use them to our advantage a little bit. So good job, grade 12. You didn't have to look at this video, but you took the time to, and you're pushing yourself, and that's really admirable. Good job.